Before I get into the details of using column sets, I need to talk about some of their restrictions. Because like sparse columns themselves, column sets have a few restrictions. So some of the more interesting restrictions include the fact that you can't change a column set once it exists in the table. Instead, you have to drop it and then recreate the table. You can't add a column set to a table that already has sparse columns. So this is probably the most severe restriction. A table can have only one column set, which encapsulates all of the sparse columns in that table. And there can be no constraints or default values on that column. Remember, it's essentially an updatable computed column that stores no data directly. So this restriction kind of makes sense. SQL Server Books Online documents some other restrictions, so be sure to check that out. One of the things that you might try to do when starting to work with column sets is to add a column set column to an existing table that has sparse columns. So in this case, I have a table called dog that contains sparse columns, and I'm going to try to add a characteristics column. This is the name of the column. Its data type is XML. Column set is XML data. Use the column set keyword and specify 4 all sparse columns. Now, when this feature came out in a couple versions of SQL Server ago, we saw the 4 all sparse columns and thought, oh gosh, sometime in the future, we're going to be able to create a column set for a subset of the sparse columns in a table. Well, that's not a feature in SQL Server 2012. I don't know if it's ever going to be a feature in SQL Server, but this is the only option. You have to include all of the sparse columns in a table in the single column set column. Okay, so I'm going to go ahead and run this code. And as you can see, I get an error message. It says, cannot create the sparse column set characteristics in the table dog because the table already contains one or more sparse columns. A sparse column set cannot be added to a table if the table contains a sparse column. Okay, so I can't do it. I could, however, if I wanted to execute an alter table statement on a table that doesn't have sparse columns, I can add sparse columns or change columns to be sparse and add a column set at that time. So I can use this on an existing table, but I can't if the table already has sparse columns. So I've got 3 options to work around this problem. One is I could delete and recreate the table, creating the column set along with the sparse columns. Or I could delete all the sparse columns and create an alter table statement that adds them back along with the column set all at once. A little bit drastic. Or I can create an entirely new table. So for purposes here, I'm going to use that third option. So I'm going to create a table called dog CS. Nothing magic about the CS, but it just is to distinguish it from the dog table, which doesn't have a column set. And then the only difference in the schema is that I add this characteristics XML column set for all sparse columns. All right, so I'll go ahead and create that table. Okay, we're good to go. And then also go ahead and add the same initial data as I did to the dog table, the regular table that doesn't have a column set. Again, nothing different about this code, just straight insert. As far as the insert statement goes, there's no indication whatsoever whether or not this has sparse columns or not. All right, so I'll execute that, and now we have a bunch of rows in the dogs table. Okay, here's where things start to get interesting. I'll execute a select star from dog CS. Now, instead of getting all of the sparse columns as separate columns in the result set, I get all of the non-sparse columns and then just the column set itself. And this is XML data. Like other XML columns, I can click on that link and see the raw XML. Okay, so just by virtue of the fact that this table has a column set, a select star now behaves differently. This is, frankly, yet another example of why select star statements are not good, because they can end up returning dramatically different results. I might be counting and getting all those sparse columns back, but now I'm just getting a single characteristics column. Okay. But just to compare, I'll run both these statements, So this is a select star from dog, the table that has sparse columns but no column set. And there's the difference. So I get the characteristics column, or I get all of the individual sparse columns within the results. But otherwise, the table acts normally. If I want to return all of the sparse columns, I can do a select statement and include the columns that I want to retrieve, and then they're retrieved individually. And I can also explicitly retrieve the column set column along with other individual columns in the table. And it's not an either-or. I can mix sparse columns with column sets. So here I'm retrieving dog ID name, a couple of the sparse columns, as well as the column set. And that works just fine as well. So it's really just the select star that's a little bit weird, and you get different results. Okay, now, column sets really become useful when you insert or update data. You can provide an XML snippet as the value of the column set, and then that populates the underlying sparse columns. Okay, so for example, I have an insert statement here that is going to add the data for Raja. So I have Raja, birth date, some of the settings, and then I want to populate all of the sparse columns using the characteristics column. So I'm including that within the list of columns for the insert statement. So this is an alternative to providing a value for each of the sparse columns. I can just put it all within XML here, and then SQL Server will take care of spreading it to the different fields. And I'm explicitly setting Raja's birth date and her weight. So I'll go ahead and insert that. And then, if I execute this statement, which is going to select dog ID, name, birth date, handedness, and characteristics for Raja. And there you can see the data. And in particular, it's taken the birth date value, right here, from the column set, actually the input for characteristics, and put it into the birth date column. So it takes care of shredding the data into the appropriate columns. And because there was no handedness data that was passed in as part of this XML, that value is null. Okay, you can also update existing sparse data using the column set. So here's an example of an update statement. It's pretty much a regular update statement. It's setting characteristics to this data here, and it's for Raja. So I'll execute that code, and then once again look at the results there. And so now Raja's weight is 53, and we're marking her as a leader. But wait a second. What happened to Raja's birth date? Well, the reason it was set to null is because it wasn't included in the value of the column set in the update statement here. So you can update values using a column set, but it's important to include all non-null values in the value of the column set field. SQL Server is going to set to null any sparse columns that are missing from that column set value. Okay, now one limitation on updating with a column set is that you can't update the value of a column set and any individual sparse column values in the same statement. Instead, you have to write two different statements. All right, so in this code here, what I'm doing is I'm attempting to update the dog CS table, setting characteristics to weight 53 and leader 1, and also setting the sparse column birth date to a value as well for the Raja record. Execute that, and I get this message: the target column list of an insert, update, or merge statement cannot contain both the sparse column and the column set that contains the sparse column. Rewrite the statement to include either the sparse column or the column set, but not both. So what I need to do is, if I really want to do this separately, maybe I have a snippet of XML that has this data, but not the birth date, then I would have to do two update statements. And that's the way around that problem. The column set has data type XML, so you can use all of the methods of the XML data type as well. So for example, this code here, uses the query method of the XML data type. Characteristics is an XML data type, so it has that method on it. And what this does is this extracts the weight node from the XML data. So I can execute that, and there you can see we get just the weight node with her weight set to 53.